Welcome to the third installment of Nye's Night Notes. Here we have Chapter 5, Lesson 4, the Distributive Property. And if we look at the distributive property, we're looking at going from that idea of A to B and A to C. And I will show you exactly how all that works as we tackle this distributive property. So, first we got to stop, we got to listen, and we got to write this down. We just got one definition today, distributive property. And all we need to know is multiply each term inside the parentheses by the number outside of the parentheses. We're distributing some numbers throughout the parentheses. Throw this definition into your notes and then click continue when you're ready to go. To help us put a picture and visuals to what this distributive property is representing, first we're going to start by just using some ideas about variables and numbers. So if I have this picture up in the corner here, we're looking at representing this as x plus 2. I have one x and two units, or two things, so I'm taking those as a combined of x plus 2. And I forgot to mention to you just listening through this part, I'm going to have you write down something at the very end. So what if I want to take that x plus 2 and I want to multiply that by 2? So now I'd have a picture that would look something like this. Or I have that x and my two individuals, and then I have two groups of those. So I went from having x plus 2 to now 2 times x plus 2, because I had two groups of my original, 2 times x plus 2. So now I can rearrange those, because remember, if we talk about looking at what that information means, I have x plus 2 and now 2 times x plus 2. I could just take those blocks, rearrange them, and now I have 2x plus 4, if I just rearrange those things and look at them slightly differently. This is indicative of what the distributive property can do. So I'm going to have you pause, stop here, and I do want you to include these, because I want you to add these two different arrows from our 2. We'll talk about exactly why those purposes are there and how that shows a distributive property. So go ahead and click play once you're ready to continue. What this showed is that if I take 2 times x plus 2, first I have to take my 2 and multiply it by my x, and then take my 2 and multiply it by my other 2. I distributed this 2 to the things inside the parentheses. We go back to that first slide. And so when we looked at that example again, we took the number outside of the parenthesis, 2, and multiplied it by each step inside the parentheses to get 2 times x plus 2 times 2, which is 4. So I get now 2x plus 4. I want to go over a couple more examples to make sure that you jot these down to get a great idea about all the ins and the outs of the distributive property. But my next example is I want to go through is 4x plus 7. And just like the last one, again, we're going to take that 4 and distribute it to everything inside those parentheses. So now I'm doing 4. Remember, I have that multiplication sign right there. So that means 4 times x. That means I get 4x. 4 times 7 is 28. I keep my addition sign because we went there and I'm just kind of distributing throughout. So I'm kind of transforming this 4 into my entire addition sequence. So make sure that you're getting these written into your notes. I'm going to go through another example on this page still. Now what if I have negative 2 times x minus 8? So now you see that I transformed from an addition sequence to a subtraction. And now I have a negative number on the outside. I'm still going to distribute, so kind of kick that negative 2 into both parts. But now I'm going to get negative 2 times x, which a bad thing happening to a good person is still bad, so I get negative 2x, because again we don't know what x equals, so I'm now just kind of writing that as 2 times x. And so now I distribute that negative 2 to the negative 8 again. And now I'm going to keep mine as minus, because now I have negative 2 minus positive 8. Negative 2 times 8, or times positive 8, gives me negative 16. So now I'm left, as I distributed, negative 2x minus negative 16. And I know I can rewrite that because the matrix told us subtraction doesn't exist. I can rewrite that as negative 2 plus positive 16, or even more simply, negative 2 plus 16. And now I've distributed that negative 2 all the way throughout and kind of cleaned up this little middle business to make it a little more understanding of what I'm trying to do. I have 2 more examples for us to write down, so again, these will go quick, but just make sure that you are writing these into your notes. One thing that you will see is something that has complete numbers with it, so something like 4 times 3 plus 2. And again, we can distribute right in between to use this idea of the distributive property, and we should get 12 plus 8 to equal 20. But you might be asking yourself, well, Mr. Nye, why wouldn't I do this stuff in the parentheses first? Well, in this case, you actually could, because we have all numbers. But if you saw all of my previous examples, you were seeing numbers that look like 4 times x plus 2. There's nothing I can do with x plus 2 because I don't know what x equals. So now, if we have numbers there, we can use the distributive property, or we can justify our answer by doing the parentheses stuff first. And if I have this written down, I know that if I add the parentheses first, I'm going to get 5, and so now I'm just taking 4 times 5, which still equals 20. So I get my same exact answer, but now as we're getting used to the distributive property, use that to kind of allow you to understand why we can distribute those different things. One more example for us. So I don't have my symbols up top, but actually let's get those put in right now. So make sure that this last piece gets in your notes as well. And the final example is going to be just a different view. So if I have something that looks like m plus 3n, and that's in parentheses, and then I have an 8 on the outside. I'm going to distribute that 8 to both parts. Even though it's on the back side, it's still saying, remember the commutative property says this is the exact same thing as 8 times m plus 3n. I can just swap those around and I still should expect the same. So because of that, I can just distribute evenly throughout. If I rewrite that now, so I had m plus 3n, and that entire quantity times 8, again, like I said, distribute all the way through. So now, rewriting those, I'm going to have 8 times 3n plus 8 times m. Now I can simplify this a little bit because I do know what 8 times 3 is. So I can take 8 times 3, and that's 24, and then take 24 times n. Because remember, the associative property says I can do this sequence in any order. I can take 8 times 3 first, or I can take 3 times n first. I don't know n, so I'm going to associate those differently. So now I'm going to look at my parentheses being around the 8 and the 3 to get 24 first. Now I have 24 times n plus 8m. And I still don't know what n equals or what m equals, so there's nothing else I can do, because I can't add m's to n's if I don't know what those numbers mean. So if you see anything like this original problem, this is your simplified version after the distributive property has been applied. Today, with our joke of the day. The joke of the day says, how does an octopus go to war? Well, that is very easy. Octopus goes to war, well armed. Because they have so many arms. Well armed, like prepared. We got ourselves a little octopus prime there to kind of help us out. So here's the distributive property. Use this as you're working through your homework, and have a fantastic Monday. Adios.